Hello. This is a LED light. White one. Here's a green one. Here's a red one. I have blue as well. A LED light is a semiconductor. You know, semiconductors are computer chips, basically, or became computer chips. What do they do? Well, electricity does not flow through a pencil. Electrons cannot flow through a pencil. That's why we use wire. Wire is made of copper because it has the least amount of resistance. It's flexible. But what the interesting thing about semiconductor is different materials produce different colors. So who invented the LED light? The LED lights, you know, we see them all over the place, like display for thermometers and things like this. The key inventor usually credited is Nick Holoniak Jr. In 1962, working for General Electric, he invented the first practical visible light LED while working at General Electric. It produced red light. Okay, but there were earlier steps. In 1920s, Oleg Losev observed light emission from semiconductor diodes. He understood something important was happening, but LED was not practical yet. So, as we said, Nick Holoniak made the first practical visible LED in 1962. And then Shui Nakamura, Isamu Akasaki, and Hiroshi Amano developed the first practical blue LED lights, which later made modern LED lighting possible. And for that, they won the Nobel Prize in Physics in 2014. Who invented the light bulb? No, it was not Thomas Edison. What he did was bring it to market. He had the ability to industrialize things. But at the time he was working on the light bulb, many other people were working on it as well. In fact, the first light was the arc light, and that was invented by Humphrey Davy in 1802. 1879 is when Thomas Edison got his industrial scale lighting working. But anyway, the problem with the arc light was it was too bright. So they put it out in the street to light the streets up. Now they use different kind of lightings for street light. But they still use arc lights and searchlights. You can go in the hardware store and say, I want to buy an arc light. Okay, then, so Thomas Edison's light bulb was called incandescent light. Works by heating elements in a vacuum. Most of his work was to figure out what element worked. What was it? Paper? Was it silk? Was it a wire? He had to look around to find something that wouldn't burn up. But anyway, Warren De La Rue, he made a incandescent light bulb in the 1840s, for the 40 years before Thomas Edison. And Joseph Swan made a light bulb at the same time as Thomas Edison, but I think Edison and Swan met. But anyway, Edison is the name that we remember, because Edison was known, you know, he was an astute businessman. He was known for making inventions. Today we're going to look at two things that produce light: a regular light bulb and a LED. By the end of this lesson, you'll know exactly why your Arduino uses LED and not light bulbs. You'll understand enough about how LEDs work to use them confidently in your projects. At the highest level, here's the difference. A light bulb makes light by heating a wire until it glows. A LED makes light by running electricity through a semiconductor. One is basically a tiny furnace. The other is a precision electronic component. That difference makes a lot when you're working with an Arduino running on 5 volts. Heat first, light second. Inside a light bulb is a thin wire called a filament. When current passes through it, the filament resists the current, so that resistance turns electrical energy into heat. The wire gets hot enough to glow white. We're talking over 2,500 degrees Celsius. That glow is the light you see. So the light bulb strategy is get hot first, produce light as a side effect. Here's the problem with that strategy. About 90% of the energy going into a light bulb becomes heat, wasted energy. Only 10% becomes light. And the regular household bulb runs on 120 volts AC, or 220 in Europe. Your Arduino outputs 5 volts. So you cannot connect a light bulb to an Arduino pin. It simply won't work, and you could damage your board trying. A light emitting diode is completely different. It's not a tiny light bulb. It is a semiconductor device. It produces light when electricity flows through it in the correct direction. And it only needs 1.8 and 3.8 volts to do it. That puts it perfectly in range for Arduino's 5-volt pins. One important thing to notice: the LED has 2 legs, a long leg and a short leg. These 2 legs are not interconnected. We'll come back to why in a moment. What is a semiconductor? To understand how a LED works, we need to understand semiconductors. There are 3 types of materials when it comes to electricity. A conductor, like copper wire, lets electrons flow freely. An insulator, like plastic or rubber, blocks electricity completely. A semiconductor sits in between. Sometimes it conducts, sometimes it blocks. And crucially, its behavior can be designed and controlled. That's what makes semiconductors so useful. Silicon chips, microcontrollers, and LEDs are all built from semiconductors. The Arduino is a microcontroller. Semiconductors can act like switches. Because a semiconductor can be tuned to either allow or block current, it behaves like a switch. Sometimes the circuit is open, no current flows. Sometimes it's closed, current flows through. This is the fundamental idea behind every transistor, every microchip, and every LED. Your Arduino's own microcontroller contains millions of these tiny semiconductor switches, electrons and holes. Now let's go one level deeper. In a semiconductor, there are 2 kinds of charge carriers. Electrons, these are tiny negative charges that move through the material, and holes, which are simply places where electrons are missing. A hole acts like a positive charge. When an electron moves into a hole, the hole appears to move the other way. Think of it like a row of seats. Most seats are occupied. One seat is empty. When a person moves into the empty seat moves in the opposite direction. Electrons are like people. Holes are the empty seat. Semiconductor materials come in 2 flavors. N-type has extra electrons. The N stands for negative. Electrons are the main charge carriers. P-type has holes. The P stands for positive. Holes are the main charge carriers. A diode is made by joining one piece of P-type material to a piece of N-type material. The place where they meet is called the junction. A diode works in one direction. When you connect the diode the correct way, the positive voltage to the P side the negative to the inside, current flows. We call this forward bias. When you flip it around, positive to N, negative to P, the current is blocked. We call this reverse bias. That's why LEDs have polarity. They are diodes. They only work in one direction. Here's the beautiful part. When the lead is forward biased, electrons from the N side and holes from the P side both move toward the junction. When an electron meets a hole, they recombine. That recombination releases a tiny packet of energy, a photon. A photon is light. So electron plus hole, they meet at the junction, energy is released, and that energy comes out as light. That's it. That's how a LED works. Why are LEDs different colors? The color of the light depends on how much energy is released when the electron and the hole recombine. And that depends on semiconductor material used to make the light. Remember that light is wavelengths. You know, Isaac Newton studied light, made a prism, figured out that the light is waves, and waves of different lengths have different colors. It's called the light spectrum. Different materials release different amounts of energy. Different amounts of energy correspond to different wavelengths of light. Red LEDs use one material, blue LEDs use another, green another. That is why you can buy LEDs in so many colors. Always use a resistor. This is one of the most important practical rules. Never connect a LED directly to an Arduino without a resistor. Why? Because LEDs will draw as much current as the circuit allows without anything to limit that current. Too much flows through the LED and it burns out immediately. A resistor in series with the LED limits the current to a safe level. For most standard LEDs with an Arduino, use a 220 ohm resistor. That's the standard value for this job. Arduino pin, resistor, LED, ground. LEDs have a correct direction. Remember two legs that we mentioned? Here's why they matter. The longer leg is the anode, the positive side. It connects toward the Arduino pin through your resistor. The shorter leg is the cathode, the negative side. It connects to ground. There's also a flat edge on the plastic casing of the LED that marks the cathode side. If you light it backwards, the LED simply won't light. It won't be damaged. Diodes reverse block current. Just flip it around, try again. Why Arduino uses LEDs? So why does Arduino use LEDs? They use very little energy, perfect for a 5-volt system. They produce almost no heat. They respond instantly to your code. 2 lines of C code are all it takes. Digital write 13 high turns it on. Digital write low turns it off. And they give you immediate visual feedback about what your program is doing. The last point is more valuable than it sounds. When you're learning to code hardware, being able to see your program state is everything. Remember, let's recap the differences. A light bulb heats a filament. A LED uses semiconductor recombination. Light bulb wastes 90% of its energy as heat. A LED produces almost none. A light bulb needs 120 or 220 volts. A LED needs less than 4. A light bulb has no polarity. It works either way. A LED has a positive and a negative leg. Direction matters. A light bulb needs no resistor. A LED always needs one. In Arduino, a LED is not just a light. It is your first window into how electronics and code work together. Once you understand this, you understand the foundation of everything else we'll build. Okay, thanks for watching the video. Have a good day.